Let's see refraction at curved surfaces. We have a curved concave surface. On the left side we have air, and on the right side we have glass. Now, it doesn't matter whether you take air or glass. We will handle in this part whole thing in terms of mu, and that mu is basically refractive index of glass with respect to air. Light is coming from air and it enters into glass. But if they give you left side as medium 1 and right side as medium 2, then you can simply say this is refractive index of medium 2 with respect to medium 1, which is nothing but mu 2 divided by mu 1. So if they give you water and glass, then we will be discussing what refractive index of glass with respect to water. That's all. But in this article, we'll take refractive index of this medium with respect to this medium as what? Mu. Now, just like reflection, you can consider a very small portion of the curved surface like a flat or plane surface. In reflection at curved surfaces, I had told you that for a very small portion of the mirror, it just behaves as if it's a plane mirror. And then we use concept of reflections at plane surfaces, which is simply what? Angle I is equal to angle R. In here, it's a curved surface. If you take any small portion, if you take a very small portion of this curved surface, then this small portion and this part is simply what? A flat or plane surface. And whatever concept we have developed so far for refraction at plane surfaces, that is still applicable even though whole surface is what? A curved surface. Basic concept is what? Snell's law. Sin I upon sin R equals to mu. The other basic part is what? Intersection of incident rays. That gives you what? Object. Intersection of refracted rays. That gives you what? Image. These are the only basics. And after that, it's simple what? Geometry. Now, this line which passes from the center of this curved surface, in case of curved mirrors, it was called principal axis. Now this is called an optical axis. This point, which was called pole, is now called optical center. But for us, this point is nothing but origin. Anything on the left side, anything on the left side will be taken negative, anything on the right side will be taken positive. Up is positive, down is what? Negative. All the distances will take, they will be considered positive. Hope you remember what we did with reflection at reflection at curved surfaces. Now, for this curved surface, this is the center of curvature. See, center of curvature. If a point object is present somewhere here, this O is the object, Our aim is to find where image of this point object forms on this optical axis. So what we do for that? For object, for image, we always need what? At least two rays. One is this, which goes straight as it is moving along the normal itself. This optical axis is nothing but normal drawn at the skirt surface right at this position, at the middle portion, and therefore it is passing from the center. Now we need a second ray. This second ray is this. That's the second ray. Intersection of incident rays, that gives you what? Object. Now, when it meets the curved surface at this position, you will draw a normal. Let's draw this normal. That's a normal. This incident ray is moving from rarer medium into denser medium, and therefore it will deflect towards the normal like this. Let's deflect it. That's your refracted ray. Second refracted ray, first refracted ray. Intersection of refracted ray, that will give us position of image. If you produce this ray backwards, then it should be produced like this. That's how you produce it. That's how you produce it. It meets here, and this is the position of image. Let's say this point, which is optical center, let's take it as P only. This point, take it as M. Our aim is to find relationship between OP, IP and CP. Same thing we did with what? Reflection at curved surfaces. In that article we also found a relation between all these distances. Exactly same thing we'll be doing here. Over there we had a concept of angle of incidence is equal to angle of reflection. At this place we'll be using Snell's law, which is sin I upon sin R equals to mu. That's the only difference. Otherwise, geometrical part is almost same. If you say that this angle is alpha, take this angle as beta, take this angle as gamma. Same thing, same concept. Alpha, beta, gamma. Now look for angle of incidence. Angle of incidence of what? This incident ray with the normal. This is your angle of incidence, I. Angle of refraction. This is the refracted ray. This is the normal, and therefore this is your angle of refraction R. If this is R, you can see that we simply produce this refracted ray back so that it can meet the optical axis at I, which means this angle is simply the opposite angle, and therefore this is your R part. And this is R, alpha, beta, R, I, gamma. Your aim is to find relationship between all these things that will ultimately give you required part, which is OP, IP, CP, a relationship between all these quantities. So now pause the video, find out these relations, and then come back and see the solution part. Let's write down few things first. OP, IP, CP. I told you in reflection also, these all are distances. And since these are distances, you will always take them what? Positive without any sign. OP is distance of object, which is represented by U, and therefore U is minus of OP. V is minus of IP. R is minus of CP. We are repeating the same thing, and therefore let's do it fast. U, V, R, these things are taken with proper sign. OP, IP, CP, these are what distances. If you consider P as origin, then in this figure, this object is on the left side. If OP is 10 centimeter, then distance wise it's 10. But if I ask you what is U, you will say minus of 10. We have done same thing in reflection, and therefore let's not repeat it again and again. Now, let's find out alpha, beta, gamma, I, R, a relationship between all these quantities. First of all, this is alpha. This whole thing is I. And if you look at the triangle OMC, in triangle OMC, alpha and I, these are internal angles, and gamma is the external angle. Therefore, alpha plus I is what? Gamma. Now, look at the triangle IMC. If you look at this triangle IMC, in triangle IMC, this is I, this is M, this is C, beta, and look at this. This is your angle of refraction, which is R. Beta and R. Now they become what? Internal angles. External angle is again what? Gamma. So you get what? Beta plus R is what? Gamma. Now, we will need tan alpha, tan beta, tan gamma. That will give us all these required bases. Perpendicular will be M, and you will drop a perpendicular from M onto this optical axis. It falls at P dash, and again PP dash will be approximately 0. P dash is approximately what? 0 because of small aperture. Same thing, if you take large aperture, different rays coming from O after refraction will meet at different point on this optical axis, therefore creating multiple images. And we are not interested in that. We keep the aperture size very small so that all the rays after refraction meet at single point. For that purpose, if you say the aperture size is small, automatically your PP dash becomes what? 0. If PP dash is 0, this OP is nothing but OP dash. This IP is nothing but IP dash, and this CP is nothing but CP dash. Now, so we need relationship between these distances. That means we are not interested in I and R. We need to get rid of I and R. We just need these base angles. And if you just need to remove this I and R, then what will you do? Sin I upon sin R is what? Mu. Mu. Light is entering from air into glass. Snell's law, sin I upon sin R is what? Mu. What's the value of I? I is gamma minus alpha. Put it here. Gamma minus alpha divided by sine of R. What is R? Gamma minus beta. Sine of gamma minus beta, which is mu. Now, since angles are small, aperture size is also very small, and therefore all the angles are small, which means sine can be easily removed. Sine theta becomes what? Theta. That means you can say that this whole thing is nothing but gamma minus alpha upon gamma minus beta. That's the relation between all these base angles. Once you found this relation, let's readjust this whole part in this form. This is mu gamma minus mu beta, mu gamma minus mu beta equals to gamma minus alpha, equals to gamma minus alpha. Now from this part, always remember this thing in your mind, that you will have to keep distance of object and distance of image on the left side. Now, what are those things which will give you distance of object and distance of image? Alpha will give you distance of object, and beta will give you what? Distance of image. And therefore, from this point onwards, try to keep alpha and beta on the left side. Alpha and beta on the left side, and take gamma to the right side. It becomes alpha plus mu beta, alpha minus of mu beta, alpha minus mu beta equals to gamma minus mu gamma. Alpha minus mu beta is gamma minus mu gamma. Now, this alpha is nothing but tan alpha. Remember, angles are what? Very small. Beta is what? Small again, and therefore the equivalent to tan beta, and your gamma is nothing but tan gamma. From this point onwards, pause the video and try to find a relationship between U, V and R with proper sign. And you can do that. Put down this much, pause the video, try to find the relation between all these things. So, we can write this equation in this form. Tan of alpha minus mu times tan of beta equals to 1 minus mu into gamma, which is tan of gamma. All the angles are small, and therefore sine theta becomes theta, tan theta also becomes what? Theta. Now what is tan alpha? Tan alpha is perpendicular, which is MP dash upon base OP dash. Tan alpha is MP dash divided by base, which is OP dash, minus of mu times tan of beta. What is tan of beta? MP dash MP dash divided by IP dash. That's your IP dash equals to 1 minus mu multiplied by tan of gamma. Tan of gamma is coming MP dash divided by CP dash. NP dash, NP dash, NP dash, all these things get cancelled, and finally, this becomes what? 1 upon OP dash. What is OP dash? Minus of U, minus of U, minus of mu divided by IP dash. What is IP dash? Minus of V, minus of V equals to 1 minus mu divided by Cp dash, and your Cp dash is coming minus of R. This is minus of R. Now the whole thing is what? This is minus minus plus mu upon V minus of 1 upon U. Take the negative sign inside, mu minus 1 divided by R. This is the formula which we need for refraction at curved surfaces. It relates object distance with image distance in terms of radius of curvature. We have solved this whole thing considering concave part opening on this side, but equation is valid even for a flat plane surface. It's valid for convex surface. It's also valid for a flat or plane surface. Just look at this part. For a flat surface, for a plane surface, what is R? Infinite. Radius of curvature. Radius is what? Infinite for a flat part. 1 upon infinity is what? 0. And therefore this thing for plane surfaces, will become what? Mu upon V minus of 1 upon U equals to what? 0. Now what is this? This is V upon U equals to mu. Shift, cross multiply, V upon U equals to what? Mu. If you consider the whole surface, curved surface, as a flat surface like this, then for this flat surface, object was called what? HO. Image was called what? HI. That's what you see. What is V? It's equivalent to HI. U, HO. Mu I divided by 1, if you can see that, is nothing but object. Object is in air, image is in glass. Same formula, it can convert itself to HI upon HO equals to mu I upon mu. You can mention this thing as a side note. We are basically interested in refraction at curved surfaces. Now, always remember this format like this. V, image, U, object, R, radius. Take them with proper sign. Again, this mu is what? Refractive index of this side with respect to this side. refractive index of this side with respect to this side. Now, in this whole part, if I ask you what type of image do you see, real or virtual, at least for this figure. For a different figure, this image can form somewhere else, but for this given figure, this image, if I ask you, is in which medium, then many a times you will say that image is in air. No. Same concept of image formation is still present. Image forms in the medium of refracted rays. This and this, they are present in glass, and therefore their intersection will also take place in glass, which means image is present in what? Glass. But it appears in what? Air. That means there is a contradiction, and because of that contradiction, we say that this image is basically a virtual image. Now, if you look at the object part, then this object is an air, intersection of incident rays. These two incident rays, they are present in air. Their intersection is an air. It also appears in air. There is no contradiction, and therefore this object is very much a real object. Note down everything.